Hi everyone, welcome back to Spring into Math 7. I'm Mrs. Campbell, and today we're going to be doing a review of what we've learned so far in Chapter 3. So let's get started. I quickly wanted to take a minute to go over some of the words that we've been using lately in this chapter. The first thing I want to talk about is the word expression. And remember, an expression is basically a math problem that's just not been solved. An algebraic expression is a math expression that uses numbers, variables, or symbols. The word equivalent means that expressions have the same value but don't look the same. And order of operations, otherwise known as PEMDAS, P-E-M-D-A-S, and that tells us the order in which we do operations when we're solving an equation. P for parentheses, E for exponents, M for multiply, divide, add, and subtract. So just a quick review of some of our terminology. Okay, so one of the things I wanted to talk about today was expanding expressions, and this is going to help us when we're looking for equivalence, and I'll explain a little bit more what I mean by that in a minute. But first of all, I just want to focus in on what I mean by what it means to expand an expression. Let me just read the whole definition to you as it's written here, this explanation. To expand an expression, we can use the distributive property to remove the parentheses and see what the expressions look like. This can help us see if expressions are equivalent. Let's take a look at this problem here, this term, 4a. Now, 4a is actually the same thing as 2 times 2a. 2 times 2a is actually just the expanded form of 4a. Although they look different, they are in fact equivalent. We've just broken down 4a. And we can also combine like terms to expand an expression. And let me show you what I mean by that. We have 3a plus 4b. Now what I've done here, switch to pen. 3a, I have actually broken it down, this 3a, into 1a there and 2a's there. So you can see there's 3a and then there's 1a and 2a's. 2 times a. And right here I have 4b. I can break down 4b as 3b plus 1b. So you can see that these are in fact going to be equivalent. Okay, the next thing I've done is I've moved all my a's together. So I've got 1a and 2a together. Sorry, 2a's there and the 1a there. And all my b's together, 3b and b, and I can do that because the commutative property tells me that I can. And then I add them together and I have 3a plus 4b. So you can see I've got this way and this way. These are two different ways that we can find equivalence in 3a plus 4b. All right, moving along. Let's practice. We've got 5 times 6a minus 3b plus 14b. Does that equal 30a minus b? First thing we want to do is our distributive property. 5 times 6a is here minus 5 times 3b, negative 3b, plus 14b. I'll just bring this down here. All right, now we're just going to multiply. That's what the order of operations tells us to do. 5 times 6a equals 30a. 5 times negative 3b is negative 15b. Bring on down our 14b. And now we just solve. 30a plus negative 15b is 30a. And, excuse me, this 15, let me back up. Okay, actually, let's start over here. Negative 15b plus 14b equals negative 1b. And then we bring our 30a down. 30a plus negative 1b actually equals 30a minus b. Well, is that equivalent? Yes, in fact it is equivalent, 30a minus b. So the distributive property and the order of operations helped us find equivalence. Okay, we can also use the substitution principle to look for equivalent expressions. So what I've done here is I have substituted for anywhere where I see the variable b. And if the expressions on both sides of the equal sign work out to be equivalent, then I will know that they work. Okay, so let's take a look at this. 3b squared, 3b minus 2 squared, is that the same thing as 3b squared minus 4? Okay, so these are the two things we're talking about. So the first thing we want to do is we're going to substitute 4 as the value of the variable b, which I've done here. So now I have 3 times 4 minus 2 squared and 3 times 4 squared minus 4. I need to do what's in the parentheses first. 3 times 4 minus 2 is 10. So now I have 10 squared. And 3 times 4 squared is 16, minus 4. Now I have 3 times 16 minus 4. 3 times 16 is 48, minus 4. Okay, 10 times 10, or 10 squared, is 100. And 48 minus 4, that's 48. So those are not equivalent. But the whole point is substituting 4 in for the variable of b helped me determine if they were equivalent or not. That could be helpful. All right, if an expression cannot be simplified any further, you can sometimes still create an equivalent expression. And what I mean by this is we can break down expressions into smaller little pieces. Let's take a look at an example. I have 5m minus 10. That cannot be simplified any further. However, I can break it down into smaller pieces. For instance, I can show 5m as being the same thing as 3m plus 2m, right? And we'll just leave my 10 the same for now. And I can actually even break this 10 down farther. I could say 10 is equivalent to 6 minus 4, right? So if you think about it, we started with this expression, 5m minus 10, and it is in fact equivalent to 3m plus 2m minus 6 minus 4. It's just broken down. One of the ways we can break down expressions is by factoring. And I really like this little chart because it gives you kind of a graphic visual of how it would work. Let's take a look at the light blue box. Let's start with 5m minus 10. We want to break each one of these terms down into factors. 5m, the factors of 5m are 5 and m. That's pretty simple. And the factors of negative 10 are negative 1, 5, and 2. Anytime you're factoring a number that's negative, factor it as if it were positive and just include a negative 1 in the list of factors. Then what you're going to do is look at the numbers listed that are the same. In these two terms, in 5m and negative 10, the 5 is the same. So we can put that on the outside of the parentheses. It's almost like we're creating the distributive property in reverse. And then the numbers, the factors that are not the same will go inside the parentheses. In this case, it's m, negative 1, and 2. And I just multiplied, you could just multiply the negative 1. Let me show you what I'm talking about. This negative 1 and the 2 to create negative 2. So actually, 5m minus 10 is the same thing as 5 times m minus 2. And here's a couple more examples here that will show you how you can, a few more practices. If you want, you can pause the video, work these out yourself, and see if it makes sense to you. I did want to call your attention also to this light peach box at the very end. It's just a good example to show you that sometimes no factors are the same. And if that's the case, you can't find any common factors and put a number or a variable outside the parentheses if there are no common, if there are no common factors. Okay, the last thing I want to do is quickly go over how you might do this. Okay, the question asks us to write two equivalent expressions for 16b minus 12. First, let's factor. We have 16b. The factors of 16b are 2, 2, 2, 2, and b. 4 2's and a b. And then we have, for negative 12, the factors are negative 1, 2, 2, and 3. Okay, don't worry about the colors, purple and blue and green right now. Just focus on these 2's. The first thing I'm going to do is find the factors that are the same. So here's 1, 2. That's the same. Here's another 2. Oops, there's another 2 that's the same. So 2 and 2 are the same. We've got two 2's, which when multiplied together gives me 4. Well, that is what I will put on the outside of my parentheses. Now, inside my parentheses, I'm going to use all the purple factors, or the factors that are not the same. And that's what I've written here. All the purple numbers or variables. The numbers and variables that are different are negative 1, 2, 2, 3, and b. Now I plug those in. Now I'm over here. 4 times negative 2, 4 times 2 times 2 times b times minus 3. To get the minus 3, I just multiplied the 3 by a negative 1. And then once I solve within the parentheses, I get 4b minus 3. And it comes out to 4 times 4b minus 3. So that is another way, or an equivalent way, of writing, that's 1, 16b minus 12. But remember, it asks for 2. So here's 1. We can write it as 4 times 4b minus 3. Or even more simply, I could just write 16b minus 12 is the same thing as 10b plus 6b minus 12. That should be 12. All right, guys, that just about wraps it up for today. Thanks so much for joining us, and we'll see you next time. Bye-bye.